So welcome all. I continue the video lecture series. So today we discussed this video. We discussed Einstein's theory. So in earlier we discussed absorption, spontaneous emission, stimulated emissions of quantum theory of radiation, and now determination of Einstein's coefficients A and B. So the Einstein's theory of absorption and emission of light by an atom is based on Planck's theory of radiation. Also, under thermal equilibrium, the population of energy levels obey the Boltzmann's distribution law. So now under the equilibrium, so we consider lower energy levels of atom in E1 and higher energy levels of atom E2, and the rate of excitations from E1 to E2, isn't it? So the rate of absorption, that is equal to rate of emission. So therefore balancing the equations of absorption and rate of stimulated emission and the rate of spontaneous emission. So that is equal to R1 to directly proportional N1 rho N1 R1 N1 and rho B12, and R21 is that A21 N2 and B21 rho nu, isn't it? So the rate of spontaneous emissions from E2 to E1, R21 directly proportional N2 A21 equal to N2 A1, and the rate of stimulated emissions from E to E1, R21 N2 B21. So therefore the higher energy state in the atoms are written back to the lower energy state and then emit photons. So the thermal equilibrium, the rate of excitations is equal to the rate of spontaneous emissions plus the rate of stimulated emissions. So therefore N1 rho nu B12, that is equal to N2 A21 plus N2 rho nu B21. So therefore so we know that rho nu equal to A21 divided by B12 N1 N2 minus B21. So therefore we know the Boltzmann distribution law. So from the Boltzmann distribution law, N1 equal to N0 e power minus E1 divided by kBt, and N2 equal to N0 e power minus E2 divided by kBt. So we know that kB is that Boltzmann constant, and T is the absolute temperature, and N0 is that number of atoms at absolute zero. And therefore, so at equilibrium we can write the ratio of populations levels as follows: N1 divided by N2, that is equal to e power E2 minus E1 divided by kBt. So now N1, so we know the value for E2 minus E1, that is equal to h nu. So we have N1 divided by N2 equal to E h nu divided by kBt. So in substituting we have the equations A21 divided by B21, that is equal into 1 divided by B12 divided by B21 e power h nu divided by kBt minus 1. So this equation have a very good agreement with Planck's energy distribution radiation law. So that is equal to rho nu equal to 8 by h nu cube divided by c cube into the 1 divided by e power h nu divided by kBt minus 1. So comparing the equations, so we get A21 divided by B21 equal to 8 by h nu cube divided by c cube. So the ratio of A21 B21 is proportional to y cube, and spontaneous emission dominate over stimulated emission. So A12 divided by B12 should be less than 1. So we need to have much stimulated emission as possible for laser action. See, because of the significance. So because this is a higher energy state and this is a lower energy state, and this is a population inversion. So thank you. We discuss in the next session.